Hey everyone, and welcome. Today, we're jumping into a really crucial design pattern that helps you write flexible and scalable code, the factory method. You know that feeling when a super clean project slowly turns into a complete mess as new features get bolted on? Well, you're about to see a powerful way to stop that from ever happening again. Let's dive in.
So let me start with a question for you. Think about the most successful apps you use every day. Now think about some of the most tangled, nightmarish code bases you've ever had to work on. What could those two things possibly have in common? The answer is actually pretty simple. It's growth. Simple as that. As your app gets more popular and everyone wants new features, that beautiful code base you started with can quickly become complex, rigid, and just a real headache to maintain. Ironically, success is often the thing that breaks your initial design. All right, so let's walk through a scenario that I'm sure is going to feel very familiar. We'll call this section The Code That Grew, and it's the classic story of how feature creep can sneak up on any project.
It all starts so innocently, right? Your app needs to send some emails. Easy. You whip up a simple class, and life is good. But then the product team says, hey, we need SMS too. So you add an if statement. Then comes push notifications. Okay, another else if. Before you know it, bam! Marketing's at your door asking for Slack alerts, then WhatsApp, and your once simple logic is a total mess.
And this is what leads to what our source material perfectly calls nasty code riddled with conditionals. You end up with this monster if-else block or a giant switch statement that you have to change every single time a new notification type comes along. This isn't just messy, it's super fragile and it just flies in the face of good design principles.
Okay, so now what? Well, usually the first step people take is to at least try and get that mess out of their main business logic. And this leaves us to our next section, a simple, imperfect fix. Basically, we're just centralizing the chaos for now.
So, the idea behind a simple factory is to create a clear separation. Over here on the left, you've got that tangled logic we started with. But on the right, you can see we've moved all that creation logic into its own dedicated factory class. Now your main code is so much cleaner. It just has to ask the factory for a notification object. And it doesn't care how it's made. It's a step up for sure. But we haven't really solved the core problem, have we? We've just kind of moved the mess into a different room. So what's the new bottleneck we've just created?
Well, here's the catch. That factory class itself, it's now the bottleneck. It's the one place that holds that giant brittle switch statement. And this completely violates a core principle of good software design, the open-close principle. The whole point of that principle is that your code should be open for extension, but closed for modification. And with this setup, every time you want to add a new notification type, you have to crack open this central factory class, which is super risky.
And this, right here, brings us to the really elegant solution. This is the core idea of the factory method pattern. Instead of centralizing the decision, we're going to delegate it. And this is the real aha moment.
Let's use an analogy to make this super clear. Think about a food delivery app, right? A simple factory is like having one single, massive, chaotic central kitchen trying to cook everything. Pizza, sushi, tacos, you name it. It's a mess. The factory method, on the other hand, is like letting each restaurant have its own specialized kitchen. The main app doesn't need to know how to make sushi. It just tells the sushi bar, hey, I need an order.
So here's the key difference, the real shift in thinking. A simple factory centralizes all the control in one place, but the factory method, it distributes it. It pushes that decision-making down to specialized subclasses, where each one knows exactly what it's supposed to create.
So, what's the textbook definition? Well, the factory method is a creational pattern where a superclass provides a kind of template. Think of it like a slot for creating an object. But, and this is the crucial part, the actual object that gets made is decided by the subclass that fills in that slot. That's why it's sometimes called a virtual constructor. It's like a constructor you can override.
Okay, to really get this, we need to look under the hood. So let's break down the anatomy of the pattern. There are 4 key players here that you need to know. First up, we have the product. This is basically the contract. It's an interface or an abstract class that says, hey, whatever object we create, it's guaranteed to have these methods. So in our example, it's a generic notification interface that has a send method. Simple enough.
Next, you've got your concrete products. These are the real deal. They're the actual specific classes that implement that product interface we just talked about. So this is your email notification class, your SMS notification class, and so on. You get the idea. These are the things we actually want to build.
Okay, participant number 3, the creator. This role is absolutely crucial. It's an abstract class, and it's the one that declares that factory method we've been talking about. But here's the thing, it doesn't actually implement it. The creator has the business logic, it knows when to send a notification, but it leaves the decision of what kind of notification to its subclasses.
And that brings us to the final piece of the puzzle, the concrete creators. These are the subclasses that actually roll up their sleeves and do the work. Each one overrides that factory method to spit out a specific concrete product. So an email notification creator will always return a new email notification object. This is where the decision is finally made.
So, let's just put it all together real quick. You have the product, that's the interface. The concrete product, that's the implementation. The creator, that's the abstract class with the creation slot. And the concrete creator, that's the specialized factory that fills the slot. When you see all four parts working together, you can really appreciate how flexible this system is.
Okay, we've gone through the problem, the structure, the whole shebang, but now for the most important question. Why does any of this matter? What's the real payoff for doing all this?
Well, here's why it's such a game changer. First, you totally avoid tight coupling. Your core logic isn't welded to a specific email notification class. It just knows about the abstract notification interface. And this makes your system incredibly easy to extend. Need to add Slack notifications? No problem. You just create a Slack notification class and a Slack notification creator. You don't have to touch a single line of your existing working code. That is huge for stability.
And what's really cool is that this pattern isn't just some random good idea. It lines up perfectly with those core solid principles you always hear about. It nails the single responsibility principle by moving creation logic into its own dedicated classes. And, like we've been saying, it is a textbook example of the open/closed principle, which is the key to building systems that last.
So when should you pull this tool out of your toolbox? Definitely use it when you know you'll need to create objects, but you don't know the exact types up front. It's also perfect if you're building a framework and you want to let other developers extend your components easily. And a bonus use case, you can even use it for things like object pooling, where you want to reuse expensive objects like database connections instead of creating new ones from scratch every time.
So I'll leave you with this one last thought to chew on. The factory method pattern is more than just a way to create objects. It's a philosophy. It's about anticipating change and designing your code so it can grow without breaking. So take a look at your own projects and ask yourself, is my code just built to solve today's problem, or is it truly designed for tomorrow? Thanks for watching.